Hello and welcome to quantification theory. Now, quantification theory is the last chapter or last part of our syllabus which we will be covering in this course. The best way to understand quantification theory is with the help of symbolizations, and I will use this approach because I will be taking a lot of questions, lot of symbolizations, lot of propositions, and we will be symbolizing it, and we will see what is its difference from the propositional logic. So classically speaking, quantification theory is also sometimes called as predicate logic, though it may not be the exact synonym of quantification theory, but we basically make a distinction between predicate logic and propositional logic. So what we have studied up to now was basically propositional logic, and what we are planning to take is right now the topic or the area is basically called as predicate logic. Now, predicate logic is basically an extended understanding of propositional logic, though there can be a debate whether the predicate logic came first or the propositional logic. Nonetheless, we have to understand certain basic tenets of predicate logic, and we will see it vis-a-vis propositional logic. Very simply speaking, or in very simple words, if you see, propositional logic is more like when we have an instantiation. However, predicate logic will be like when we are dealing with a general proposition. However, singular propositions also occur in predicate logic. Let us try to understand the difference. You can always search in Google, or you can search a lot of video structures and materials, and you will find a lot of material on that. So I am refraining from going to that kind of discussion, and let us try to understand with the help of some symbolizations. Let us take a simple example. Like if I say that Delhi is the capital of India. Okay, so if we have to symbolize with the help of propositional logic, so we will be symbolizing it like P, or you can always symbolize it as D, because you feel like that it is talking about Delhi, so we will be talking about like this. But in predicate logic, what we will be doing is that we will take, say, the capital of India is the predicate and Delhi is the subject basically, right? So we take capital of India like C as in big letter and this as a small letter. So if you have symbolized it as D or you symbolize it as CD, it is exactly the same thing. Just that this is the symbolization from propositional logic and this is the symbolization of predicate logic. It says D is C and this is exactly D, right? Now, why there is a need to use two words and this and that? Let us take an example. Like we know this example, all men are mortal. Socrates is a man. Therefore, Socrates is mortal. Okay. Now, if you use for this as P, this as Q, and this as R, so you will never be able to prove from P to Q R, even if you know that this is a valid argument. But when we will be using predicate logic, when we will be using quantification theory, so you will see that these kind of examples or these kind of questions can be very easily solved. So in order to understand and appreciate, because we have also worked on syllogistic logic, we have already solved questions on syllogistic logic, and we know that this kind of argument will be a valid argument. But then if we use the rules of propositional logic, so they will be symbolized as P, Q and R, and from there you will not come out with a conclusion. It is impossible to find a conclusion R from P and Q. So it will make this argument as an invalid argument. But that is not the truth, right? So we need to form, or we need to have ways so that we can see that how these things can be symbolized. Let us take some examples to understand that how we need to symbolize in predicate logic, right? Or using the quantification theory. Though quantification theory, in quantification theory, you will have two type of symbolizations. One are understood as singular terms, or say singular propositions and singular symbolizations. The other one are called as general symbolizations. So they can be called as, say, singular propositions and general propositions. So right now we are dealing with singular propositions. Like in the last part of this lecture, we have taken the example of Delhi is the capital of India. Similarly, if we have Ram is a boy, or Sham is a boy, or Gordon is a boy, so you now know that the symbolization of this will be BR, because you see that the predicate is boy, so I am keeping it with the capital letter, and Ram is the subject, so I am putting it as the small letter. So here it will be BS, and here it will be BG, right? So these are basically the singular terms and the or the singular propositions, and the symbolizations are like this. Now suppose if I have to say X is a boy or someone is a boy, right? So in that case the symbolization will be BX, right? So this is like a more general part of the symbolization, and this goes to the general type. However, this or this or this go to the singular type of proposition. So it is like singulars will be more like the instantiations, and general will be more like a general approach to it. But we will have quantification as well, because as you can see that we use quantification theory, or we say that this chapter is a quantification theory chapter. So what are these quantifications? Now suppose this is about X is a boy, because we do not know, it is an arbitrarily chosen variable, right? Here we know it's a specific person, Gordon. Here we know it's Sham. Here we know that it's Ram. So here we were knowing, but here it's an arbitrarily chosen thing. But then we need to sometimes talk about some or all, right? Because we have also discussed in the syllogistic logic that we need to talk about some and all, right? So the convention which we use here is like when we have to say for all X, so we will be using this symbolization. It is quite akin to the symbolization which you people use in mathematics, like this, right? Okay. And for sum, we will be using this thing, and this is exactly the same as we use in mathematics as well, or sometimes also in computer science. So this is the for all I will say quantification, and this is the their exist or the existential quantification, right? This is called as for all, and this is understood as there exist. So you now also know that all the some propositions, the I and the O propositions, are also called existential propositions, because it claims that there exists something. Here it does not talk about anything like that. So these are the two things which we will be using. Now suppose if we have to symbolize everything is mortal, suppose, and vis-a-vis we also have to symbolize this thing, something is mortal. So how we are going to symbolize it? For everything is mortal, the symbolization will be for all X, X is mortal, because we say X is mortal, right? Like Gordon is a boy, Sham is a boy, Ram is a boy, X is a boy. So X is mortal, right? And when we say something is mortal, so our symbolization will be there exists X such that X is M, right? So these are quite simple symbolizations to start with. But then you slowly and slowly try to pick the train, or try to understand the trail which we are following, that how we are moving from singular propositions to more general propositions. And these are basically the symbolizations for these kind of propositions. Let us take a couple of examples more. something is not mortal and nothing is mortal. Now, something is not mortal is symbolized as there exists X such that X is not mortal. Okay. And when we say nothing is mortal, so we say for all X, X is not mortal. The interesting thing is that this expression is actually equivalent to negation of for all X mx, and this expression is equivalent to there exists X, and we will put a negation outside mx. So either ways, if you say something is not mortal, so you can say there exists X such that X is not mortal, or it is not the case that everything is mortal, right? And when we say nothing is mortal, so you can say that for all X, X is not mortal, or it is not the case that there exists X that is mortal, right? So if you remember the squares of opposition, it will be useful for you to deduce these kind of results as well. Few more examples. The Times of India is a newspaper. Now, as you can see that this is the predicate and this is the subject. So our simple symbolization will be NT, right? Now, if Nora is not an Indian, we have to symbolize. So it will be negation of IN. If we have to symbolize Keanu is either an architect or a chef, so we will say that either Keanu is an architect or, so or will be a wedge function, or Keanu is a chef, right? So this is going to be the symbolization. And last one, I will ask you to pause the video and check it for yourself if you can do it. How will you symbolize SMVDU experiences rain just in case Bhavan or Patni Top experiences snow? Right, it's a very good question. This is the question which we have also taken sometimes in the examination. Just in case is a triple bar, so I will put a triple bar in between, and Bhavan or Patni Top experiences snow, that will be on this side. So snow is experienced by Bhavan or snow is experienced by Patni Top, and in that case SMVDU will experience rain, right? So this is going to be the symbolization for these four propositions. Now the thing which you need to understand is that these are all singular propositions. You cannot use the understanding of X over here because they are basically singular propositions and they are talking about some kind of instances, right? Because it is talking about the Times of India, which is a newspaper. It is talking about some person whose name is Nora. It is also talking about some person whose name is Keanu. And it is also talking about some place and the university. So given these kind of things, you also need to pick up that what are going to be the singular propositions so that you do not confuse with general proposition. Let us take some examples which we have already discussed in syllogistic logic. As you can see that this is an A type of proposition, this is an E type of proposition, this is an I type of proposition, and the last one is an O type of proposition. Now how we will be symbolizing these propositions, right? I have given you a small hint while I was discussing the modern square of opposition, but it was just a hint. Now let us try to understand that how we are going to symbolize these. Now when we say all dogs are mammals, what we say? We say that for all X, if X is a dog, then X is a mammal. This is the symbolization for an A kind of proposition, which is all dogs are mammals over here. If we take no cats are reptiles, now how to symbolize this? We will say for all X, if X is a cat, then X is not a reptile. Okay, so this is the symbolization for an E proposition. If you take an I proposition like some apples are green, so the symbolization is that there exists X such that X is an apple and X is green. So this is the symbolization for an I kind of proposition which says some apples are green. And when we say some rabbits are not white, that is an O kind of proposition. So what we mean to say is that there exists X such that X is a rabbit and X is not white. Okay, so these are the 4 types of symbolization for 4 type of proposition. So if you see that these two are the universal quantifiers. We have already discussed that these are the universal quantifiers and these are the existential quantifiers. The existential quantifiers are for the particular propositions. The universal quantifiers will go for the universal propositions. So that is also something which we have discussed. And these are exactly the symbolizations for A, E, I and O type of propositions. Now, there are a few more things which you need to understand, that how to read this. When we say for all x dx implies mx, it says for all x, if x is a dog, then x is a mammal. This is something which you should understand, which you should practice, because once you will get to hear this thing simply and clearly in your mind, then you will not be faltering on any kind of symbolization. When I say no cats are reptiles, so I say for all x, if x is a cat, then x is not a reptile, right? So this is the symbolization. When I say some apples are green, I say there exists x such that x is an apple and x is green, right? Because this is what we say when we say some apples are green. And when we say some rabbits are not white, so it says there exists x such that x is a rabbit and x is not white, right? Because we are saying that there are rabbits which are not white. And here we say that there are apples which are green. Here we say that no cats are reptiles. And here we say that all dogs are mammals. So you need to also understand it from the logical point of view, that how we are symbolizing these propositions. Let us take few more examples. The first one is snakes are reptiles. Now as you can see that there is no all which is used, or there is no some which is used. Now the beauty of these kind of sentences is that you need to understand the language. English is not exactly a language which will be very logical by nature, right? Or again, it will follow the rules and regulations of logic as we require it. But then we need to understand the meaning of that proposition, and then we have to symbolize it. Now, whenever we say snakes are reptiles, we actually mean that all snakes are reptiles. We do not mean that some snakes are reptiles. So given this case, our symbolization will be for all x, Sx implies Rx, right? So this is going to be the symbolization for this proposition. Now, suppose if we have to symbolize children are present. Now, it is not the case that when we say children are present, it's like all children are present. It means that some children are present. This is the idea. It can be all as well, but the assertion precisely means, and moreover we are talking about the presence of something, the existence of something. So we need to understand that this will go for the existential proposition. So here it will be there exists x such that x are children and x are present. So this is the symbolization. Now let's come to the next one, which is a little bit tricky one. When we say only citizens can vote. Now whenever we say only citizens can vote, whether it will be all citizens are voters or all voters are citizens. Now try to understand. Whenever we say only citizens can vote, now this has become a necessary condition. And as you know, that necessity will go on the other side of the implication. That means it will become the consequent. It never remains as the antecedent. So if you remember, it is always S implies N, right? So whatever has become the necessity, only citizens, now this is the necessity. So this will go here and this will come. So the symbolization will be for all x, Vx implies Cx. That means all voters are citizens. And in fact, it is a true statement. If you see, all voters are citizens, but not all citizens are voters, right? Because citizens can be below the age, say in our country it is 18, in some other country it can be some other thing. So given that understanding, all those who have voted are citizens, but all citizens can vote? No, it is not the truth. So this is also a true statement, and this is how it is understood. Now, this can also create some confusion. Animals exist. Now, few people will symbolize it as there exists X, ax dot ex, but actually there is no need for ex, right? So you do not need ex because existence is already guaranteed with the quantification. So you just need to put it like this: there exists x, ax, right? So anything is conceivable. It is also like this for all x, cx, right? It is more or less the kind of example which we have discussed. And unicorns do not exist. It will be like this. Now let us take few more questions or few more examples which are also tricky by nature and which requires a little bit of thinking before we can actually go on to symbolize them. Let us talk about the first one. When I say apples and oranges are wholesome and delicious. Okay. Now if we have this proposition, how to symbolize it? Now as you can see, there are apples and there are oranges and they are wholesome and they are delicious. This is the thing which we have to symbolize. Now the symbolization can be for all x, ax dot ox implies wx dot dx. More or less, for the first time, when students symbolize it, they will symbolize it like this. But this is not the right symbolization. This is an incorrect symbolization. Why it is an incorrect symbolization? Because if you read this, it says for all x, if x is an apple and x is an orange. Now what does it mean? When we say x is an apple and x is an orange, it means that x has to be an apple and also has to be an orange. And as you know, no apples are oranges or no oranges are apples, right? They belong to two different fruit categories, right? So this way of symbolization, even if it is written as apples and oranges are wholesome and delicious, will put us at a, say, it will be incorrect. Now what can be the symbolization for it? The symbolization for it is either it is an apple or it is an orange. Now this is the right symbolization, right? So for all x, if x is an apple or, does not matter, here it is and written, but you need, look, the understanding is that irrespective of the way the language is written, the natural language is written, you need to get the exact expression of this over here in the machine language, and the machine cannot falter, right? So you need to explain it properly, that what is going to be the case. If x is an apple or x is an orange, then x is wholesome and x is delicious. Here we will not use or, because this wholesome and delicious can be together, right? That it will fill your tummy and it will be delicious. These two properties can exist together, they exist together. But a same fruit is called both as an apple as well as an orange is not the case. So these small changes or small ideas you need to understand, you need to pick, and you need to symbolize them properly. Let us take two more examples for us to understand that how we, and these will be the last examples for this lecture, that how we need to think about these symbolizations. The first one is, there are happy marriages. Though it is not the truth, but still, if it is said or if it is written, so irrespective of the fact that it is a true statement or a false statement, we need to symbolize it, right? So let us first take that how this is going to be symbolized, right? So there are happy marriages. It is a false statement, I must say that, but still we need to symbolize it. So it is difficult for me, but still it may be easy for you to symbolize it. It is symbolized as there exists X such that X is happy and X is married. For men, it cannot be the case, but still, if it is written, so it is written. Okay, let us take the second example. All that glitters is not gold. Okay, now how to symbolize this? All that glitters is not gold. What does it say? It says that there is something which glitters, but then it is not gold. Right? Whenever we say that all that glitters is not gold, we mean to say or we want to say that there is something which glitters, but it is not gold. So the symbolization will be there exists X such that X glitters and X is not gold. But now since you can see that for glitters I am using G, so for gold I can use, I will be using A, because aurum will be in chemistry, na? So I will use it as AX. So it says that there exists X such that X glitters, or X is a glittering object or something like that, and X is not gold. So that is the understanding. Now this expression is equivalent to, it is not the case for all X. If X glitters, then X is gold. So if you see, both these expressions are equivalent expressions, right? So you can also understand that if I put a negation on an A proposition, it will become an O proposition. Similarly, if I put a negation on an O proposition, it will become an A proposition. It is like this. So you see that this was an O proposition, so I can represent it as negation of an A proposition. So you need to also understand that how you can understand a proposition, right? Because sometimes it is difficult for you to understand it from an A point of view, so you can understand it from an O point of view. Sometimes it is easy to understand it from an E point of view or an I point of view, or vice versa. It depends. So there are ways to catch hold of questions and try to symbolize them properly. Okay, so this was it for today's lecture. So I thought that I will take some examples for you to understand that how you need to work with quantification theory and how you need to understand the difference between the propositional logic and the predicate logic. And as I told you in the beginning of this class, that quantification theory is best grasped if you do a lot of symbolization, lots and lots of types of symbolization. In the next lecture also we will follow this trail only, and till that time keep trying, keep solving.